What do you need to do?
Count.
What's the first step? Okay, let me highlight everything. As I mentioned, this tool needs to be initialized and put into the memory first. Right? And what else? You need to know n.
Yeah.
What else? You need to know where is memlog, where to store the data. Okay? So these are the things you need to do first. So you can do whichever one first. So let's say we take out small n first. I use R0 to store my n. Okay, so get n. Okay, that's the first step. Okay, let's not go to the instruction first. So you need to get n, you need to get the address of memlog.
Yes.
And you need to store
The even
0 and 1 into memory. What else? Why you want this number n?
as a counter.
Because later it will be a counter, and you count how many times you need to do this. How many times you need to do this?
N minus
N minus 2.
Yeah.
Okay, so basically you need to do n minus 2. Okay? So that's the initialization. Then you have your loop. In your loop, what should you do?
Wait,
Again, what's the repeat actions we just summarized?
add and store.
Calculate and store, right? So first one, you need to calculate the new number, right? And then, okay, let's finish the instruction here so that I can refer to the registers. So get n is load. Okay, so I will do this very quickly. I hope you don't have problem at this moment. So LDR R0 n. Okay. Next one, address of the target memory. I use R1. So LDR R1 equal memlog. Next one, store 0 and 1 into it. How to do that? Store 0 and 1 into memory. Store 0 and 1 into memory. What's the direction of the data?
Into the memory.
So the instruction you need to use is definitely str, right? Because you are going into the memory.
Yeah.
So str will be R1, right? Because R1 is the address of here. But you cannot write like this because here you cannot use an immediate value. It must be a register. Okay? So what you can do is you just use one of the register. Okay, say you see here I'm using R2 to hold the first data, R3 to hold the second data.
Okay.
Can you see that?
Yeah.
This is necessary because later on, while you are doing calculation, you still need two numbers to do calculation.
Yeah.
So I want these two registers to always hold my first and second data. Okay? So in this way, we are moving. Okay, we need to set move R2
is 1 with 0. Move
Then you can
R3
do str
数的话直接移到
R2
to R1 adjust.
R1.
Adjust.
Then how to write?
R1 pause.
R1 is now pointing to this, right?
Yeah. Okay, then
I mean, you can do this. Then you do MOV
R3 with 1
1, then
store.
R3 to the new location.
Yes.
Which means your R1 is no longer pointing here, your R1 needs to point here.
Yes.
Okay, which means R1 needs to be updated before this instruction. You can use, can you add something here?
The one
Como #4. You can do post index. So once you store the first element, your R1 is get updated, so your R1 is pointing to the next location.
yes.
Okay, and then you do
R1
R1.
same.
Do you still need post index?
Need ba? Need ba?
No.
Need. Oh no.
H4.
You need, because your task is not finished yet, you need to go on. You need to keep going down.
Correct.
Okay? So this allows your R1 get ready somewhere here. Okay? So basically these are the 4 lines for this step. Store 0 and 1 into memory. Then how to update your N? Where is it now? Where is your N now?
And this R0.
Yeah. So how to decrease your R0?
Sub X. R0 minus 2. Yeah.
Okay? So these are the initialization. Now everything is ready, you are here. Okay, you are going to do the next step, and what's happening is, okay, let me write here. Your R1 is basically holding 0, correct? Your R2 is basically holding 1. Okay? Then what's next? We are in the loop now. Okay? Well, you know that you are in the loop, so when you construct your instruction, you need to be careful that whatever you write here can be done repeatedly. Okay? So, what do you need to do? Firstly, calculate the new number.
Yeah.
Right? How to calculate the new number? And you definitely need to add R1 and R2. Right? But which registers you need to use?
R4,
Definitely you can
R2.
use R4. Okay, let's say use R4.
R2 and R3.
Sorry, R2 and R3. You are adding these two numbers and the result is stored in R4. If you do that, basically R4 is putting this value.
Correct.
Right? And then you are going to store this value into
R4.
memory.
Yeah.
Okay?
R1.
But always remember, whatever you write here, later on you will come back to this again. Right? But next time when you come back, let me use another color. You are going to calculate this value. Right? So you are going to calculate this value in order to use this command again. Can you see that? At that moment, your R1 needs to be stored this value and your R2 needs to store this value. So that you have to do, sorry, R2 and R3. This one should be your R2. Okay, here I made a mistake, sorry. So at the beginning, this one is R2, this one is R3. So these are your two elements here. See here? This one, this one. Right? So what I'm saying here is you can use R4, no problem. But later on, actually is you will take 2 steps, which means you want your R2 to store the 1, R3 to store this one. So that when you go back to your loop, you do this, you can calculate this one. Okay, you can imagine your R2 and R3 are 2 boxes, should always holding the latest 2 data. Okay, you need to refresh them. Okay? So you see, actually here we can save one more step. Instead of saving it into R4,
with R2.
you can save it into R3.
R3. Oh.
Okay, you can save it into R3 so that you don't need to later update your R3. Okay, just like the tutorial 2, question 2, like we have ADD R2, R2, R2. You ask whether all these three can be the same register. They can, because when you are doing the calculation, you take out the data already. After your calculation, you are free to refresh this register. Similar here. When you do this, your R3 is the data you are using is the old value of R3. Okay, and the old value of R2. Then your calculation will be stored in R3. There's no problem of that. Okay? So by doing this, you already move your R3 here. Okay? So what I'm writing here is add R3,
will be 1.
R2, R3. Then what's next? You have calculated the value and the value is now in R3. Right? So basically you have calculated this one. R3. So what should you do next? You can update R2. How to update R2? See the current situation. Once you have calculated R3, I should erase here. Can you see that? This is the current situation. Look at my drawing here. Your R2 is still holding 0. Your R3 is holding 1. Now what you want to do is, you want to make your R2 equals to this value. But this value is actually lost already because your R3 is erased. Can you see that?
Correct.
But, how to let R2 get this value?
The pointer.
Now your R2 is 0, your R3 is 1. How to get R2 equal to 1?
We just get R2 from.
Sorry?
Load the memory location, the value to R2.
You want to go to the memory and take out the value.
Yeah.
Any other suggestions? Okay, let's think about a very another case. Let's say now your R3 is getting this value and your R2 is like one step away. Now you want your R2 get this value. How to get that value? You know 5, you know 2. How to get 3? Minus. So how to write here? Sub, the destination should be R2, right? You sub which one?
R3, R2. Oh, 天哪.
Okay? So, after writing this, now your R2 is here. Definitely you can achieve this by writing many lines. But what I'm saying here is, you can simplify it or you can optimize your program like that, okay? If your logic is clear, okay, and optimized, you can save a lot of lines. Definitely you can use many registers, you can use up to R12. But is it necessary? No. Okay, so you see, here, after these 2 lines, you move your R2 and R3 already. What's next?
Compare. Check.
What should be the thing in your loop? Always remember those 2 things. 1, calculation.
Store.
Second,
Store.
store.
Oh yeah, store.
We haven't done store yet. Okay? Your result is in R3 now. How to store? str R3. What's the address now? Who is pointing to the location now?
R1.
R1. Then? 4. Okay? Because you know that you are going to repeat this step. Your R1 needs to move down one more slot. Okay? So you are pointing here.
Stop.
Okay, so this thing can be done repeatedly. So basically this finish all your tasks in loop. But okay, what's next? Adjust your counter. See when is the situation to go back, when is the situation to finish this loop, right? So who is the counter? R0 is your counter. Then sub S. R0. How many?
2. Oh, 1, 2.
You just generated this one and store it back. You finished the one data only. Okay? Then basically you are making decision about this, right? Based on this. So you want to go back with certain conditions, so it's B something. You go back to loop. So B what? Okay? Then you are done. Okay? So this is an optimum way to do this task. You can definitely write like more lines to finish this. But what I'm saying here is whatever you write here should be repeatable. Okay? Should be repeatable. Whenever you write a line, just think about it. What will happen for next time? What will happen for next time? If it's not ready for next time, you need to add a few lines below so that you get prepared for the next run. Okay? That's how you construct your loop. Okay? There's a very last sentence here. Sorry, I think something I forget. No, I forget. I just want to share. What happened for my slides? What happens for my slides? Okay, what I'm saying is, just now in question 4, the rotation and the shifting thing. Okay, so I'm saying that you have those options like LSL, LSR, and ASR, RX, right? So people are not, actually those are defined by the programmer. They have particular usage. Okay, for example, the one, is it power off? Okay, what I'm saying is they have special purposes. That's why people design that kind of shift or rotate. Those will be useful for some calculation. Okay, so maybe I will show it to you next week. Okay, so thank you very much. Okay, by the way, I have clinic session this Saturday. If you have questions about the assignment, you can come. Okay.